All right, so we're going to look at the fundamental theorem of algebra. And really, I don't want to spend too much time talking about the theorem itself. I want to look more at how this is applied, what it means to us. And really, we're going to focus more on a corollary idea than we are on the theorem itself. Okay, so if you recall, when we were looking at polynomials before, we were only looking at the real numbers because we wanted our zeros that we could graph. Okay. However, we saw sometimes that the degree, while the degree might be 4, we might only get 2 real zeros. However, the fundamental theorem of algebra says that if we have complex numbers, which we do now, this is all of it, but I want you to focus in on this part that I've underlined, okay? In the complex number system, every nth degree polynomial function has precisely n zeros. In other words, whatever your degree is, n, tells you exactly how many zeros you should have. Okay? The degree should equal or will equal the number of zeros. I give you an example here. F of x equals x to the 7th minus 3x to the 5th. What's the degree of the polynomial that we have here?
12. 7.
7. The highest exponent here is 7. Okay, so that's our degree. So, according to this, since it's a 7th degree polynomial, we should have 7 zeros. Okay? Now, if I were to factor this, I factor out an x to the 5th. I have an x squared minus 3 left in the parentheses, and if I identify my zeros, I would just get 0 and then positive or negative root 3. Okay. Yes?
There, why did you point out multiple 0, 5?
Well, I pointed that out actually because you'll notice we only got 3 numbers. But the fundamental theorem of algebra says that we should get 7 zeros. Okay? Well, this still works because the multiplicity of 5, that's a 0 5 times.
And then 2 more?
Then the positive radical 3 and the negative radical 3 give us a total of 7 zeros. Okay? So, no matter what the degree is, that's how many zeros we have. Multiplicity, they each count as a separate 0 even though they're the same value when we're counting them for the fundamental theorem of algebra. Okay? So, I don't want you to get bogged down too much in the theory of this, but understand what this means. If you're asked to find all the zeros of a polynomial that has a degree of 5, how many answers should you be giving? 5. Alright? So, keep that in mind. It's real easy to miss that fact. Okay? And usually, when students miss it, it's because one of the zeros has multiplicity. Okay? And they've forgotten to identify the multiplicity there.
With that problem, would you have to say 0 with a multiplicity of 5?
Yes, if a 0 has a multiplicity, you should identify that. Alright, the next thing I want to look at is, it's called the linear factorization theorem. Okay, it's called a linear because we can factor any polynomial down to a product of these linear factors. Notice x is to the first power, but notice also x has a coefficient of 1. So the question is, what about ones like this? Here, x doesn't have a coefficient of 1. Here, x is squared. But there's no real good way of factoring it that we can see. So how do we handle those types of things? Well, if you think about it, remember when I gave you zeros, you wrote equations by putting sets of parentheses with x minus whatever that 0 was. Okay? When you guys found zeros using synthetic division or the rational zero test, you guys found them and then you were able to write it out in a factored form using x minus whatever that 0 is. Alright, so this is kind of an extension of that concept. But think about this. If you had this set of parentheses after you had factored a polynomial, what 0 would you get out of it? Close. Negative 1/2, alright? So, this is equivalent to x minus a negative 1/2, right? Right? Okay? Now, are those two expressions equal?
Yes.
Is 2x plus 1 equal to x plus 1/2?
No.
No.
No. However, what it is an alternate way of factoring. Okay? Can anyone tell me what I could do to make this look like this? What could I do to this? Huh?
Divided by 2.
Yeah, or instead of dividing, factor out the 2, right? So really, that's what we can do. And you'll notice here, we have this a sub n. That's why we have the a sub n there, is because of that we're going to have to factor things out sometimes to get it into this form, where it's just a plain old x, in this case plus 1/2. Okay. So how would we write this one?
X plus 5/3.
Well, you can put 3 on the outside and then x plus, or x minus 5/3.
Okay, good. And just minus, right? Yeah, it's like you could factor out a 3, and then it would be x minus 5/3. Okay? Now, the reason why I point that out, or the reason why I have this up here, is because think about factoring this. If you took the time to factor this, whatever way you chose to factor it, you would have something like this. You'd have 3x minus 5 times x plus 2. Okay? Well, you could then factor it out 3 times x minus 5/3 times x plus 2. And notice, now we have this polynomial written in the same form, oops, that we're looking at. Okay? We've got an x minus 5/3, we've got an x plus 2, and hey, that 3 is the a out in front.
Is just 3x plus 2 times x minus 5.
No, that would give you a plus x in the middle. Because if it were,
But this is plus x.
hang on,
It would be minus 6.
You have to change the
oh wait, 6 minus 5, yeah, you're right, that would be plus. Okay. Rather than change all the factoring, I'll change the original problem, since I made it up in the first place. Alright, thank you.
All of mine.
Okay, what?
All of mine.
Alright, any questions about rewriting these in this form? Does that make sense?
Yes.
This is really, really helpful when you're given zeros and you're asked to write an equation, as we'll see later on here. it's really nice to remember this. You can just write those parentheses. And by the way, you guys already did this earlier in this chapter. In fact, there was a problem like this on your quiz. The difference, however, is that now we're able to deal with complex numbers. Okay? I had never given you any that had complex numbers in there before. But if you look at this, x squared plus 25, you guys were always taught you can't factor x squared plus 25. You can only factor it when it's the difference of two squares, right? You can only factor it when it's a squared minus b squared, right? Well, if I wrote this as x squared minus, what would I be subtracting?
Minus.
25.
Minus 25, right?
So
think with me here.
You have to.
I times square root of 5.
Close. Just 5,
5.
right? Remember, you get conjugates. X plus something and x minus something. And remember, when you're factoring the difference of squares, you take the square root of this term, right? The square root of negative 25 is 5i. Okay? Yes?
Can you also do the quadratic formula and plug in 0 for b?
You can. You can. There's a lot of ways you could do this. You could even just, set it equal to 0, subtract 25, and then square root both sides. And you get plus or minus 5i. Right? There are a lot of ways you could do it. I just wanted to show you, because of our context here, notice even something like this, we can take it all the way down to these linear, x is to the first power, linear factors. Okay?
This is just this isn't solving, right? This is just manipulating factors.
Yes.
Okay.
Yeah.
Can you solve it from here?
Well, if we had it into an equation, the zeros would be negative 5i and positive 5i.
That's maybe like, can you solve this? It's fine with zeros.
Yes.
Please do that again. How we do this?
Okay. We said there are basically like 3 ways that you could do it. If I were given this and I wanted the zeros, I could use the quadratic formula, and b would just be 0, because there's no linear term in the middle. I could look at it as the difference of squares, but since that's plus, it's minus a negative 25. And then my conjugates would be complex numbers, because I've got the square root of negative 25 here and here. Or if you were trying to find the zeros, you could just set that equal to 0, subtract 25, and square root it. So we have 3 different ways. And
That's much easier.
even if you were asked to factor that, if you don't see that, that's okay. Find out what these are, and then you can work backwards. Once you know x is plus or minus 5i, you know, okay, well, that means I can write it as x minus a positive 5i times x minus a negative 5i. Just like we did when we knew we had positive zeros. Or not positive, real zeros. Okay? When we had zeros of 2, you put them into parentheses as x minus 2, right? If we had a 0 of 3, you put it in as x minus 3. Well, now we have a 0 that's imaginary, and that's okay. You just put it in the parentheses, just like you would any of the real ones. Okay? All right. Now, take a look at this problem. Okay, actually left the answer up accidentally, but how would we get there? How do we solve
X
this?
squared times x plus 4.
We have this.
Oh no, x times
You
x
take out
squared
an
plus
x.
4.
Good. We're factoring out an x. If I want to find the zeros, I'm setting this equal to 0, and I'm going to factor out an x. So x squared plus 4. Okay?
And then your x squared minus either.
Okay? Yes, and you could keep factoring this. At this point, you could go about it a couple of different ways, just like we said with the x squared plus 25. This is the same concept. You could identify right now that one of the zeros is 0, and then somehow you need to figure out what would make this 0, the x squared plus 4. So like Isabella said, you could see it as x squared minus a negative 4, and then that would factor into x plus.
2r times x minus 2r.
Very good. X plus 2i and x minus 2i. So then our zeros are 0, negative 2i, positive 2i. And that's what we have over here. If you don't like doing this, then don't do it that way. Okay? If the problem said you had to factor it all the way down, you could still get here if you figured out what your zeros are some other way here and then plugged them into your parentheses. Okay? If you don't like this part, then go off to the side, say, okay, well I'm going to solve it like this. What makes this 0? Subtract the 4, and take the square root. So, okay, my zeros are plus or minus 2i. Alright, so I'm going to come back here and write my parentheses. X minus a positive 2i, and x minus a negative 2i. Alright, so you could either factor it first, then get the zeros, or get the zeros and then write it in a factored form. It's up to you. Yes?
There has to be 3 zeros, right?
Yes, there have to be 3 zeros because of what we said at the very beginning, that fundamental theorem of algebra, our degree is 3, you have to have 3
And
zeros.
also, like in the quizzes, if you say there's 3 or like whatever, 4 zeros, depends on the multiplicity, are you gonna give any points for it?
What do you mean? Like if it's supposed to have multiplicity and you don't identify that?
Exactly.
Yeah, I'd probably take off a half point. But because if there's multiplicity and you don't say so, like on the very first problem we looked at, if you didn't say this, you only identified 3 zeros. And what does the problem say we should have?
So
7. So you're missing 4 somewhere. That's because you didn't identify your multiplicity. That would be a good mental check for you. When you get to the end of a problem, look back at the beginning, make sure you have all the zeros you're supposed to have. Okay? Alright, now, you'll notice I have down here this statement, conjugate pairs of zeros. Conjugate pairs of zeros. And there's kind of an interesting observation we can make, and that is that any time you have a complex zero, both conjugates are going to be zeros of that polynomial. Okay? This is what it says. You don't need to write this all down, but the main idea of this is that if a plus bi is a 0, then a minus bi will always be a 0 of that function. Okay? So conjugate pairs of 0 will always be zeros of the function. Okay? So in other words, if I were to tell you that 3 plus 2i was a 0 of the function, what do you also know?
3
minus
minus
2i.
Exactly. 3 minus 2i would be another 0. Okay? Yes, Tristan?
Is that because of the square root is plus or minus?
Yes, it actually does go back to your quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Where does the imaginary part come from? It comes from this radical.
Yeah.
And that radical is always plus or minus. Okay? So if you've got an imaginary portion, it's always going to be plus that and minus that. There's how we get the conjugate pairs. Alright? So that's a great observation. It does come straight from your quadratic formula because the radical's plus or minus. Alright? So. Alright, any questions about finding the zeros? Alright, now, here's a little exercise for us. This is a standard kind of situation where we're going to really tie everything we've done in the entire chapter together into one problem. Okay? Find all the zeros of the function. Okay?
Besides,
Find all the zeros of the function.
Including
So, how many answers are we looking for here?
5.
5 answers. Okay? Now, I gave you a little tip here. We need to start by using the rational zero theorem, and with that we'll use synthetic division. Okay? So, let's review real quickly here. The rational zero theorem, remember, tells us what our possible zeros are. Okay? What are
Plus or minus 1.
plus or minus 1?
Plus or minus 2.
2?
Minus 3. No, 4. 8.
Alright, somebody else, where are they getting these numbers from?
Eight.
The
8.
last one.
The factors of 8.
The factors of that constant term. Okay? 1 times 8 or 2 times 4. Alright? Then, that's a fraction, right? It's over,
The
Plus or
X
X.
yeah, the leading coefficients factors.
Which is
One.
Which
Which
is
is,
1.
yeah, it's nice when you have just 1. Okay? So, we actually have 8 possibilities.
This was the hint.
What?
This was the hint.
I gave you the hint to start with this, okay? Now, here's the deal. Before you get started, how many are we going to have to find with this in order to get to something that we can do with the quadratic?
3.
3 of them, alright?
What do you mean?
We're going to have to find 3 zeros this way before this is down to a quadratic. Okay?
How do you know it?
Well, because this is 5. So, 5, 4, 3. Then we'll have a quadratic, x squared. Once we've taken out 3 of the zeros. Let's do one together here. I'm listing my coefficients, so it's 1, 0, 1, 2, negative 12, and 8. Don't forget that 0 because there's no x to the 4th term. And what do you want to try first?
1.
1. Good choice. Alright? So we bring down this 1, then we multiply it by 1, we add down, multiply by 1, add down,
2.
multiply by 1. Sorry. That's terrible.
0.
Okay?
0, so it's
You guys get 0?
yeah.
Yeah.
Man, what is going on here?
It's not cooperating.
My brain just isn't working. or my hand's not doing what my brain is saying. There's a 2. Add down, that's 4, times 1 is 4. Add down, that's -8, times 1 is -8. Add down, and we get 0. That's what proves it's a 0, is when we get 0 at the end. Okay? So, we know that this is x minus 1 times something. Let's find what the something is. Okay? And I'm going to keep going from here. Alright? Don't use the original polynomial, because now we know it's x minus 1 times. This is an x to the 4th plus x cubed plus 2x squared plus 4x minus 8. Right? So we're going to try to divide that.
Doesn't work.
You tried -1? Doesn't work?
I tried 2, doesn't work.
2 doesn't work?
4 doesn't work.
4 doesn't work?
8.
8?
8 works.
You tried it?
No.
Why do you know it works?
It's not working.
No, we didn't try -2. Let's try -2. I think one of the other classes found -2 to work. So we'll cheat a little bit. Bring down the 1 times -2 is -2. Add down -1 times -2 is +2. Add down times -2 is -8.
0.
Add down is -4 times 2
Is 0 works.
0.
is 8, and we get 0. So now we know
That it's x plus
another
2.
factor, x plus 2. Are we down to a quadratic
No.
yet?
No.
No. So we need to find another one. Let's go with
We
purple
can use
now.
that again. We can use what we found.
Yes. Now we can use this. And by the way, you know what else is nice about this? Look at our last number. It's a 4. So,
Try 4.
Try 4.
well, we can, but I know 8's not going to work. Because I got down to a 4, right?
Make it 8.
Once you get numbers, we could kind of redo our possibilities based on these numbers. Okay? So you guys tried 4, it didn't work?
So make it
Negative.
Or did you try 4?
Yes, I did.
And it didn't work? So let's try -4.
This don't work.
Okay? Let's go, do we have purple? Okay. We'll try -4. So bring down the 1 times -4. Add down.
Doesn't work.
no.
Doesn't work.
Doesn't work.
Oh,
Doesn't work.
well that's not good.
So -8, I guess.
24, yeah, that's gonna get real big. -96, and so that doesn't work.
If we
That's
can
your
tell them that
100.
Now, is it possible we have a multiplicity?
yeah,
Yeah.
if we can tell that it's not going to work, like when we're halfway through, can we
Yeah.
just say
Yeah,
it
just
doesn't
quit halfway through if you know it's not gonna
work?
work.
Okay, just abandon it.
Yeah. Let's try 1 again, just to see. If we bring down the 1, 0, 0, 4, 4,
0.
0. Ah.
Oh, whoa.
Oh.
Okay, so 1 actually had a multiplicity of 2. Well,
At least
yeah, at least 2. So -1. There's another one, and look at what's left now. What is that?
Quadratic.
That's an x squared plus 4. It's a quadratic.
Like x plus 2, like.
Oh yeah, 7%. We can make it. All right, so now we've got a quadratic, and we can figure out. What all of our zeros are.
How do you know
It's
x squared plus 4 left? How-
Because if you follow down through, this was an x to the 5th, then an x to the 4th after we divided once. We divided again, that's an x to the 3rd. We just divided again, so that's x squared. This is our x term.
That's 4.
This is our constant term. This would have been our remainder at 0. But there's no remainder because it came out evenly. So that's how we got the x squared plus 4. So, the zeros, we already knew x equaled 1, -2, 1 has a multiplicity of 2. Alright, so I'll just write that. And then, what are the last two?
Plus or minus 2.
Plus or minus 2i. Okay?
Can we write them like x equals 1, x equals -2, and then you write x equals 1 twice to indicate
If you want, yeah, that's fine.
Okay, I'm just making that the same.
When you're graphing it, you will want to recognize, because it affects your graph, right?
Right.
If I were graphing this, these would not show up. Listen, please. We have 3 more minutes. Please listen. This would not show up on our graph at all. But 1 being a multiplicity of 2 will affect the graph, because remember, we're going to come down and touch 1, but we're going to turn back around and go the other way. Okay?
Because it counts as 2 zeros.
Yeah, it counts as 2 zeros, so you're hitting it and it kind of bounces it back.
What if it's